Alright, so next on Mason or IMA High Command standards for the IQ and PT test, we're going to get into some issues about local topologies. Okay, so inside here, there's going to be different buildings, different forts, different, what would it be? Compartmentalized standards inside here are going to have radically different costs, but basically we need a box, and that box is going to be a grid, whether it be the recruiter station or a department inside of whatever boot camp you got, or regional model MN later on. Let's call it a local topology. Where am I going to do these tests? Where am I going to conduct these tests? How am I going to go through the information on those tests? How am I, what people and standards are going to go into these models later on? When we augment this standard in some way, before we get into some of the tearing apart some of the D&D models. The D&D models are great, but I think they're a little bit too comprehensive for how fast you got to go through that material. I mean, it's great when you're just trying to throw together some party, or great, I got to make a character card for somebody and I'm just going to throw together the thing. But what artifacts they carry, what weapons classifications that they actually have, that can be all made up, at the D&D level. In the real world, we don't have that. I got to have some kind of testing parameters. I got to have, let's see. Yeah. I got to have that planes card. Otherwise, it really isn't in hand, So I have to find some way to really be able to apply that plane into there. Some kind of test that says you can get out there with a nunchuck or a bow staff or a M4, M1, whatever variable that is, based on the testing parameters that we can all share by the standards. And before I can give you the advantage to say you're allowed to carry that on your character card for the standards of what we put out over there, or however the trajectory on that situation is going to work, the potential momentum and how that'll affect in a certain way, I got to deal with the range, right? I got to deal with this area and make sure I'm functionally locally dealing with that area. It's how we compensate for the general relativity. Otherwise, every time I design a thing, the mechanics of the computer has to be the same. I can't have two different computers, an HP and a Mac. I cannot take that kind of risk inside of the situation. So, in lieu of that situation being a problem, hand-on models, right? I mean, I can't necessarily argue with the results on this kind of standard, and they are great by how they are presented and how the droid thing works inside here, and I'm not arguing that it'll be a much faster way to do this, but let's assume we're starting from scratch. Let's assume that the reason we get some of the grants or some of the standards or cost ratios on this is that somebody over there can actually fucking handle this problem. And the way to do this is to do this in an overall department of, call it ARIMA 69, whatever, I don't care. Inside of what that standard represents, and I got to be able to make sure that we have a department, ROTC, to be able to handle this information correctly. And then we can kind of go about, so what I have to do in the stone mill is, the area inside here. And I don't really give a damn if the stone mill is like this and there's a property line over here. I'm not actually physically stepping into that neighbor's property. This is all meta fucking space inside here. And it really says, hey, that's fine. That's what that is. We can say that's the area Gustin's inside of here, and I can break that down into the quadrants in this area right here, because I don't necessarily care about these straight lines. This only works great for scale and determining, well, the stone mill is 500 yards across, great. That's what that is. But in that department, the area for what that is inside here is somebody's detail, right? And inside of there, these are the field graders, these are the sawyers and operators, the management's up over here, and the mechanic shop's over in here, and it kind of deals with everything inside here. And whatever range is left back over is yard maintenance or management field. That's what they take care of. And it might be a sub-department of the management field or a ground operation, and it's a great way to kind of close off that detail, so that's taken care of. And then whatever comes up is a variable. And when that variable comes up, I can say, ooh, whose department now is inside of there? I can add it to one of the keys, not in necessarily alphabetical order for what the standards represent inside here, and I can just add it to the bottom. Or I could say off of that scale on the next page, these are some of the variables. And again, this is a hard problem to do it in a binded book. You know, this is going to be more set to a 3-ring binder standard or files or something under that model where it's actually functional to do this. But I want you to take that challenge on, because it's going to give you a good guidepost about how to design those PDF files and 3-ring binder models. I mean, we all kind of know the OSHA standards on the chemical analysis. There's diesel, gasoline, and they got whiteout in the office. You know, there's a lot of acids for stones and treatments that the customer might call you in on, or whether you think it's worth the cost ratio to now bring that in there into that company. It may and it may not be. Let's look at what kind of cost ratios, other problems, while trying to figure out Plinko all the material, and it's like I got too many other problems to try to augment a cost on here unless you can rationalize. Too many problems to be able to augment that situation. They augment the problem in itself, the augmentation of that situation, and then the MN on that variable, whether it's even practically or locally worth it to go through those standards, X, Y, and Z functions for what that does, because some sites might be able to, that they've functioned enough problems in here to make the augmentation. Hey, you know, we're looking for cost ratios right now. That's something we could take on, or that's something that we can't take on right now. And even though that might not be locally applicable, you're going to have to explain to me why that the long game trajectory on these things is worth the compression of these states, because that compression works like a pipe bomb. When that thing breaks the housing on here, it's not just going to fail, it's going to fail violently. And we want to make sure that we're registering the physics on that. We're red shifting or blue shifting the physics correctly inside of here in a quantum mechanics way, that we're breaking down physics correctly to be able to determine that result. So I just wanted to touch on that notation inside here before we get into the world building or dungeon building standards, because at this point in time, they're both the same thing. This is a global map that might have a very relative scale where that's applied, and equally locally how, even though that number is so large at that scale, when you're down in the stone mill, you know, that doesn't matter. When you're in a certain recruiting station for what those values are, it can, you know, that would be that M1, M2, MM variable inside here where it's like, look, we got to have, you know, they may not have did great on the standards for what it did for the recruiting policies, but they speak a different language. And that's a language we don't have a lot of around here, and they speak it fluently. Now, I can train, you know, proper complex conjugatives and vocation, and I don't just mean that to proper English. I mean that to situational trainings and standards inside of those things that would be almost common sense at that point in time to say, off of those tests and those parameters, what do they need that is going to make them the best well-rounded standards before they decide to go Ronnie Coleman for world's strongest man or whatever that variable comes into being it. Because we all know, you know, Ronnie Coleman, he's going to take a knee to his little old lady, isn't he? You know, when it comes down to the standards of what that represents. Why? Because the trajectory on those things are more beneficial to do it in that manner. You know, if that's a personal, local kind of thing that you have to take into consideration, and that's something I can test, that's something I can train you on, that's something I can say, well, here's all the moving parts, which ones of those things best apply to you, and we'll test those parameters inside of there, and then we'll start to go through testing you on what variables are left over inside of here to begin to increase your bar graphs on what those correlate to against everybody else's standards, or even if it's worth it to do something like that. And again, that's going to start to be a fair way to deal with Constitution and whether I've discriminated you or whether you think the case is correct on that, and whether you think it's fair at that point in time to go through those systems. Now, there's always going to be a fine line between those situations that really kind of make it, ooh, you know, that situation was right on the borderline and it could have gone either way. But 66.6, man, to your 33 1/3, you were on the wrong angle inside here. 50-50 on the standards. You know, we really have to consider those ratios correctly by X and Y to correlate whether your number zeta at the zenith high and zenith low were really actually correct, to idealize whether it was something that happens commonly, and then we can check for prime later. When that thing starts to come up, we'll know that there needs to be a situation or a way to handle this that is correct with the least amount of friction to divert that function in a way that we want. I just don't want to divert it off into some standard or some category over here to the chaplain, because the chaplain will get masked out, the sharps guy will get masked out in terms of the material, and I'm going to be going off from that on mission command by how to re-augment or reorganize this situation in such a way. Maybe the details, maybe the actual physical universe as it's set into the standard. Hey, this is big stuff, guys. Got to pay attention to it. So, catch you on the next one.